Afternoon. Today we pass on to the third lecture on electrodynamics. Today's topic is electric field due to a continuous charge distribution and the problems based on electric field. At first we can see what is continuous charge distribution. A configuration of charges which has a number of discrete stationary charges is called a charge distribution. A configuration which has a number of discrete stationary charges is called a charge distribution. The net electric field at a point is the vector sum of the individual electric field due to each charge. ഒരു കണ്ടിന്യൂസ് ഡിസ്ട്രിബ്യൂഷൻ ഓഫ് ചാർജ് എന്ന് പറഞ്ഞാൽ ചാർജുകൾ ഒരു പ്രത്യേക സ്പേസിൽ ഡിസ്ട്രിബ്യൂട്ട് ചെയ്ത് കിടക്കും കണ്ടിന്യൂസ് ആയിട്ട്. അപ്പം അതിൽ നിന്ന് നമ്മളൊരു പോയിന്റ് പി അതിലെടുക്കുകയാണ്. ആ ഡയഗ്രമാണ് നമ്മളിവിടെ കാണിച്ചിരിക്കുന്നത്. ആ പിയിലുള്ള ഫീൽഡ് കണ്ടുപിടിക്കുക എന്നുള്ളതാണ് ഇലക്ട്രിക് ഫീൽഡ്. പിയിൽ എന്താണ് അത് കണ്ടുപിടിക്കുക എന്നുള്ളതാണ് നമ്മുടെ എയിം. A continuous distribution of charge consists of many number of electric charges distributed in a region, and we have to find the electrical intensity at a point P from the charges. And we can see that each charge will produce its own field at the point P. Let Q1 be the first charge, Q2 be the second charge, Q3 the third charge, etc. Qn the nth charge. The electric field due to a single charge, we know it is given by E is equal to 1 by 4 pi epsilon 0 Q by R square. The first charge Q1 is at a distance R1 from P. The second charge Q2 is at a distance R2 from P. The third charge is at a distance R3 from P. And so on. So we can calculate the electric field at the point P. The field at the point P is given by E is equal to E1 plus E2 plus E3 plus etc. En. Or we write it is equal to sigma EI, where I is equal to 1, 2, 3, etc. That is, the electric field at the point P is a summation of all the fields produced by the charges. The first charge produces a field E1 at P, the second charge produces a field E2, the third charge produces a field E3, etc. And writing the values, we can write E is equal to 1 by 4 pi epsilon 0 into Q1 by R1 into R1 cap plus Q2 by R2 into R2 cap Q1 by R1 square. The equation you again note. E is equal to 1 by 4 pi epsilon 0 Q1 by R1 square into R1 cap plus Q2 by R2 square into R2 cap plus Q3 by R3 square into R3 cap plus etc. That is E is equal to 1 by 4 pi epsilon 0 sigma I Qi by Ri square into Ri cap. And this is the electric field due to N charges distributed. For a continuous charge distribution, that is, we cannot count, there are infinite number of charges. If there are infinite number of charges in the distribution, then we have to replace summation by integration. If the charge distribution, charges in the charge distribution can be counted, we can take the summation expression. If the charge is continuous, infinite charges, we replace summation by integration. So the electric field due to a continuous charge distribution E vector is equal to 1 by 4 pi epsilon 0 integral dq by r square into r cap. The electric field ATP due to a continuous charge distribution is given by E vector is equal to 1 by 4 pi epsilon 0 integral dq by r square into r cap. Now we see some problems. Some problems in electric field. The first problem is a monopole field problem, very simple. And it is written here, problem number 1. Calculate the electric field at a distance of 1 angstrom from an electron. ഒരു ഇലക്ട്രോൺ വെച്ചിരിക്കുകയാണ്, അതിൽ നിന്ന് 1 ആങ്സ്ട്രം ദൂരെ ഒരു പോയിന്റ് ഉണ്ട്, ആ പോയിന്റിൽ ഇലക്ട്രിക് ഫീൽഡ് കണ്ടുപിടിക്കുക. Find the field at a distance 1 angstrom from the given charge, electric charge, electron. So you know the field equation is E is equal to 1 by 4 pi epsilon 0 q by r square. You know 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. Electronic charge is 1.6 into 10 raised to minus 19. The distance r is given is 1 angstrom that we converted into meter. Therefore, E is equal to 9 into 10 raised to 9 into 1.6 into 10 raised to minus 19 all by 10 raised to minus 10 the square. On simplification, we get 1.44 into 10 raised to 8 volt per meter. Volt per meter is a unit of electric field. Now we write a problem based on Coulomb's law. I shall read the problem. 3 charges of magnitude plus 6, minus 2 and plus 4 millicoulomb are situated at points A, B and C respectively on the same line. If AB is equal to 10 centimeter, BC is equal to 5 centimeter, what is the force on charge at C? 3 ചാർജ് 3 പോയിന്റിൽ ഇരിക്കുകയാണ്. എയിലെ ചാർജ് പ്ലസ് 6, ബിയിലെ ചാർജ് മൈനസ് 2, സിയിലെ ചാർജ് പ്ലസ് 4, എല്ലാം മില്ലിക്കുളമ്പിലാണ്. എ ബി സി തമ്മിൽ അകലം 10 സെൻറ്റിമീറ്റർ 5 സെൻറ്റിമീറ്റർ എന്നൊരു കണക്ക് പറയുന്നുണ്ട്. നമുക്ക് ഈ സിയിലെ ചാർജിലുള്ള ഫോഴ്സ് മറ്റു 2 ചാർജുകളും നിർമ്മിക്കുന്ന ഫോഴ്സ് കണ്ടുപിടിക്കണം. അപ്പോൾ അതിൽ 3 ചാർജ് ഉണ്ട്. 3 ചാർജിനായിട്ട് കൂളംസ് ഫോഴ്സിന് ഇക്വേഷൻ ഇല്ലെന്ന് ഓർക്കണം. നമുക്ക് 2 ചാർജ് വെച്ചുള്ള ഫോഴ്സ് കണ്ടുപിടിക്കേണ്ടത്. We have to find force between A and C first, and then force between B and C, and we have to add them vectorially. We have to first evaluate force between A and C, then evaluate force between B and C, add them according to vector addition. The force is a vector quantity. We have to use vector addition. Force between A and C, FAC. We apply the formula F is 1 by 4 pi epsilon 0 Q into 2 by R square. So FAC equal to 9 into 10 raised to 9 into 6 into 10 raised to minus 3 into 4 into 10 raised to minus 3 all by 0.15. The total distance is 15 centimeter. On conversion into meter, we get 0.15 square in the denominator. On calculation, the answer becomes 9.6 into 10 raised to 6 Newton. That is a force between A and C. Now we have to calculate force between B and C, FBC. As seen above, FBC equal to 9 into 10 raised to 9 into minus 2 into 10 raised to minus 3 into 4 into 10 raised to minus 3 by 0.05. 5 centimeter converted into meter, 0.05 the square. You know, the charge is millicoulomb. That is why a multiplication factor 10 raised to minus 3 is in the numerator. The answer is minus 28.8 into 10 raised to 6 Newton. The minus sign for force means it's an attractive force. The force Fs is attractive because the charge Fb is attractive because charge at B is a negative charge. Therefore, total force that is equal to FAC plus FBC. The two forces are added. FAC plus FBC, 9.6 into 10 raised to 6 plus. The second force is minus negative, so we write in a brace. So the answer works out to be minus 19.2 into 10 raised to 6 Newton. The force is attractive. Now we come to another important problem, which is a frequently asked question. The force distributed at the three corners of a triangle. I shall read the problem. Three charges of 20 microcoulomb each are situated at the corners of an equilateral triangle of side 1 meter. Calculate the force on each charge. Calculate the force on each charge. മൂന്ന് ചാർജ് ഓരോന്നിൻ്റെ വാല്യൂം 20 മൈക്രോകുളം ആണ്. അതൊരു ഇക്വിലാറ്ററൽ ട്രയാങ്കിളിൻ്റെ 3 കോർണേഴ്സിൽ വെച്ചിരിക്കുകയാണ്. ഏതെങ്കിലും ഒരു ചാർജിൽ ഉണ്ടാകുന്ന ടോട്ടൽ ഇലക്ട്രിക്കൽ ഫോഴ്സ് കണ്ടുപിടിക്കാനാണ്. 3 charges of 20 microcoulomb each are situated at the corners of an equilateral triangle of side 1 meter. Calculate the force on any of the charge. The charges are represented in the figure. ABC are the three corners. Side is 1 meter. Let us find the force on charge at C. So we have to find the force between A and C and the force between B and C and add them together. If one is FAC equal 1 by 4 pi epsilon 0 Q into 2 by R square, that is 9 into 10 raised to 9 into 20 into 10 raised to minus 6 into 20 into 10 raised to minus 6 by 1 square. Distance is 1 meter and the charge is microcoulomb. So we have to convert it into coulomb. 10 raised to minus 6 is the multiplication factor. The answer is F1 3.6 Newton. 3.6 Newton. Now we pass on to the second force, F2. F2 is FBC. We get the same answer based on the above calculation. So total force on C, that is F is equal to F1 plus F2. The two forces are vectors and they are directed differently in different directions. So these two forces are to be added. And for that we use the vector addition. F vector is equal to F1 vector plus F2 vector. Vector addition, vector addition, if there are two vectors P and Q, their resultant is given by root of P square plus Q square plus 2pq cos theta, where theta is the angle between the two vectors. So here F1 and F2 are the vectors, the forces. Therefore resultant force on C, that is F, is equal to root of F1 square plus F2 square plus 2 F1 F2 cos theta. That is That is root of f square plus f square, small f. We write now small f square plus f square plus 2f into f cos theta. Since f1, capital F1 is equal to capital F2 is equal to small f. We take like that. Therefore, the root is cos 60 is 1 by 2. Putting the values, we get f is equal to root of 3f square. That is f is equal to root 3f. And this small f, the previously obtained f1 or f2, its numerical value. Small f is put here. That is f is equal to root 3. F is equal to root 3f is equal to root 3 into 3.6. You know, root 3 is 1.73. So 1.73 into 3.6. The answer is 6.74 Newton. That is the answer. Now we see another problem. Problem number 4. A positive charge Q1 is 2 into 10 raised to minus 7 coulomb is placed at a distance of 0.15 meter from another positive charge Q2 equal to 8 into 10 raised to minus 7 coulomb. At what point on the line joining them is the electric field 0? രണ്ട് ചാർജ് തന്നിരിക്കുകയാണ്. അത് ഒന്നാമത്തെ Q1, രണ്ടാമത്തെ Q2. അവ നമ്മൾ ഫിഗറിൽ കാണിച്ചിട്ടുണ്ട്. പി ഇടക്കുള്ളൊരു പോയിന്റാണ്. അതിരിക്കുന്ന എക്സ് അകലെയാണെങ്കിൽ ആ എക്സ് എത്രയാണ് എന്ന് കണ്ടുപിടിക്കണം. ഈ പിയുടെ പ്രത്യേകത, പിയിൽ അന്നേരം ഈ ഫീൽഡ് റിസൾട്ടിൻ്റെ ഫീൽഡ് 0 ആകണം. Two charges Q1, Q2 given are represented in the figure. P is a point in between them. At B, the resultant field is 0. If so, what is the distance x marked in the figure? So, we apply the Coulomb's law. At B, resultant field is 0. Therefore, F1 is F2. That is F1, 1 by 4 pi epsilon 0 Q1 by x square. F2, 1 by 4 pi epsilon 0 Q2 by 0.15 minus x the whole square. When we equate these two and cancel the common term, we get an equation in the form 1 by x, or taking a root. 1 by x is 2 by 0.15 minus x. F1 we evaluate, F2 we evaluate. We equate them because at the point P, resultant field is 0. And on cancelling common factor and taking the root of the equation, square root of the equation, we get 1 by x is 2 by 0.15 minus x. This one cross multiplication, we get 3x is 0.15, x is equal to 0.05 meter. Now the point P is inside Q1 and Q2, and it is at a distance 0.05 meter from Q1. Next problem. This is a 2018 Kerala University problem, and I shall read this. It's a little difficult to read. I shall read the question. You carefully look at the problem. 2018 problem. Find the resultant electric field at a distance z above the midpoint between two equal charges plus q at a distance d apart assume Z much greater than D. I will read it again. Find the resultant electric field at a distance Z above the midpoint between two equal charges plus Q at a distance D apart. Assume Z much greater than D. So the two charges plus Q and plus Q are shown here. The distance is D. P is a point at a perpendicular distance Z on the perpendicular bisector. The distance Z is very much greater than D. So the distance between plus Q and plus Q is negligible. We find force due to first charge F1 1 by 4 pi epsilon 0 Q by R square. F2 similarly 1 by 4 pi epsilon 0 Q2 by R square. The two forces are equal and the angle between them can be taken as 0. What is the reason? When D is very small, the charges will almost coincide. So the lines, the arrows representing the two forces F1 and F2 will come in a line. The angle between the two forces will become 0. Therefore, cos 0, cos theta, cos 0, the sum of the two forces root of F1 square plus F2 square plus 2F1 F2 cos theta. Cos theta, cos 0 is 1. So root of F1 square plus F2 square plus 2F1 F2. We obtain A plus B whole square form. The root is F1 plus F2. That is 2F1 or 2 into 1 by 4 pi epsilon 0 Q by R square. And that is the answer. Q by R square is Q by Z square. Z is a distance. So 2 and 2 will cancel. We can write the total force F is 1 by 2 pi epsilon 0 Q by Z square. Now see another problem number. Next problem. The number is not shown. The next problem you understand. And this is also a previous university question and a standard question. Calculate the force and acceleration of alpha particle when it is at a distance of 6.9 into 10 raised to 15 meter from the surface of a gold nucleus. Good stuff. The nuclear radius is 6.9 into 10 raised to minus 15 meter. Mass of alpha particle is 6.7 into 10 raised to minus 27 kilogram. Charge of electron is 1.6 into 10 raised to minus 90 coulomb. And atomic weight of gold is 79. ഐഡിയ ക്ലിയർ ആണെന്ന് ഞാൻ കരുതുകയാണ്. അതായത് ഒരു ഗോൾഡ് ന്യൂക്ലിയസ് ഉണ്ട്, അതിൽ നിന്ന് ഒരു ആൽഫ പാർട്ടിക്കിൾ 6.9 into 10 raised to 15 മീറ്റർ അകലെ ഇരിക്കുകയാണ്. ഗോൾഡ് ന്യൂക്ലിയസ് റേഡിയസ് 6.9 into 10 raised to minus 15 മീറ്റർ. എങ്കിൽ നമുക്ക് കണ്ടുപിടിക്കേണ്ടത് ഫോഴ്സ് കണ്ടതിന് ശേഷം നമുക്ക് അതിൻ്റെ ആൽഫ പാർട്ടിക്കിളിൻ്റെ ആക്സിലറേഷനും കണ്ടുപിടിക്കണം. The golden nucleus and the position of alpha particle are marked there. Force we can calculate by the equation 1 by 4 pi epsilon 0 Q1 Q2 by R square. Q1 is equal to ZD, that is golden nucleus. Golden nucleus has Z protons or Z positive charges. Proton charge is small a, that is 79 E. Q1 is 79 E. Q2 is alpha particle charge. Alpha particle charge is 2E, 2 into small a, 2 into electronic charge. You know, alpha particle is 2He4. So the charge is 2E. The distance is double the distance, that is 6.9 into 10 raised to minus 15 plus 6.9 into 10 raised to minus 15, that is 13.8 into 10 raised to minus 15 meter. All values are put in the equation. That is F is equal to 9 into 10 raised to 9 into 79E into 2E by 13.8 into 10 raised to minus 15. The square. On simplification, we get F is equal to 191.1 Newton. F is 191.1 Newton. That is the force. And now we have to find the acceleration. And for that, you know, acceleration can be found by Newton's second law. Newton's law for force, F is ma. 191.1 is equal to 6.7 into 10 raised to minus 27. A, the golden nucleus mass is given. Not the golden nucleus mass, the alpha particle mass is given. We have to find the acceleration of alpha particle. So we put the mass of alpha particle, that is F is equal to 191.1. So 191.1 is 6.7 into 10 raised to minus 27 into A. That is A equal to 2.825 into 10 raised to 28 meter second raised to minus 2. And that is all with our third lecture on electrodynamics.